this question. So they told about the hybrid parameter H12. Okay, that is they're asking for the two-port network. It's very simple. Okay, something I have to just tell you about this. What is this? So for any four parameters, H12 means definitely you will be having three things: H11 and H12 also, H21, H22. Okay, these are the four because among this only they have asked H1 as a type, but you should know the remaining three. That is very important. Okay, so for these networks we will be having V1. Okay, so I just take a V1 as a right, and this is a V0. So two things are available. So I just say V1 means first voltage. You will be having H11 I1. Okay, and then plus H12 V2. And next you will go for the same voltage, so the same current. How it gives means it gives H21 I1 plus H22 V2. Okay, so listen here. One, the H starts with the 1 for voltage and H starts with the 2 for a current. Okay, and with the open shorted. Now we are having open shorted. Open shorted means for automatically you will be having a V2 becomes 0. Okay, V2 becomes 0 means so applying V2 becomes 0 in this one, in this equation, as well as this equation also. What do you have? So this term totally becomes 0. Is that right? So automatically V1 is equal to H11 I1. So from this you can get the H11 value is equal to V1 divided by I1. What we made? We made V2 as 0. And now after applying this equation, what you will have? This term becomes 0. So you will getting I1 is equal to H21 into I1. Okay, and afterwards what you have? So this one is not I1, so this is a I2. Is it right? I made a small mistake here. Don't worry about this one. I2. So you will get H21 that is equal to I2 divided by I1, and what we made? We made as V2 as 0. Is it right? So V2 is becoming equal to 0. And now because we made open shorter, and you can have it as the output shorter also. Now what you do? You'll be going for the input shorter. You're going for input shorter, and what you have means mainly you will be getting I1 is equal to 0. So there V2 equal to 0 is right. Here I1 becomes 0. And look at this. So this I1 becomes 0. You have to apply in here also as well as here also. Two things we have to just make. Okay, and what you have means, so I1 becomes 0, this term becomes 0, is it right? So the first term becomes 0. Automatically you will get a V1 is equal to H12 V2. So H12 will be having the value of V1 divided by V2, considering what we considered I1 is equal to 0. That's alright. Now take next equation. Have the I1 becomes 0, first term becomes 0. So automatically next term will prevails. So you will get I2 is equal to H22 into V2. From this you will be having H22 is equal to I2 divided by V2. H22 is equal to I2 divided by V2. What we considered? We considered I1 becomes 0. So you take what is this one? Equation number 1, H11 we found out, and equation number 2 expression, not equation, expression, H21 we found out, and H12 also we found out, and finally H22 also we found out. Is it right? Okay, now afterwards, now we can go for the simple calculation. Okay, and in this calculation, because I am writing very small, because the diagram also will come. In the calculation we want the H12, is it right? Because H12 only they have asked. So first you consider H12, which is equal to V1 divided by V2. Okay, we consider I1 is equal to 0. And now what you do? So you are going to make the current source replaced by, because I1 becomes 0 means, look at this. So here I1 becomes 0 means what? You will get the current. So this also becomes 0 means, so this area becomes 0 means what? First voltage, first current. You will be taking this one as high level, internal impedance becomes infinity. So what you have means, listen that, internal impedance I1 0 means what? Internal impedance tends to be infinite. So I redraw the diagram for the same port, and we got a Vi, and we got a Ia is equal to, okay, and we got a resistor right here, and you will be having another resistor in between the gap, and you will be got this resistor is available. Okay, R3 will be available, R3 will be available, and another port will be available, and the next one. So downside there is no issues. Okay, that's all. So here the voltage comes as you know that this is a Vi. This is a Vi. Okay, because this one is coming over here, so no issues. Vi is come over here. And here as usual, because this is a V0 set, right? So you are going to be having the next V2 new voltage set, right? So now we just apply the Kirchhoff's voltage and current law. So V1 is equal to, so V1 is equal to what do you have? So this voltage. So this voltage. So V2 into. So always this I just want to name is it, right? This one is going to be R1, and this is going to be next one is going to be R2, and this is going to be R3 because it comes in order left to right. Okay. So V2 into, because this is the main, the T network is right for T network. So in this resistor available means take this resistor as the first. So that is R2 divided by what you have. So you have means R2 plus R3. We have to take R2 plus R3. These two things you have to take R2 plus R3. Okay. What is the formula? H1 formula means what? V1 divided by V2. So in this V1, you have to make a division of V2. So automatically H1 is equal to. So in this equation, it make V2. Okay, if you do becomes means it will becomes H2. If you do so means it will become H12. V2 will get cancelled. You will get the R2 divided by R2 plus R3. That's all. So option number 4 is the right one. That's all. If you have any doubts, please comment in the comment box. I hope that there will be no such doubts. Okay, so very clear this one. Why I just taken R2 by R2 plus R3 means this voltage will not be in effect. That is what we are requiring. So this R1 will not be considered into effect because we want this one. We want this one. So automatically this one is going to be taking consideration because we are taking V2, is it right? So for the V2, what are the resistors available? Because R1 is not associated with the V2. That is one. Okay, R3 is mainly associating with the R2. So that is why we are considering R3. No need of consideration of R1. Okay, thank you very much. Please comment on the comment box if you have any doubts.